Good morning, everyone. Welcome to session 581. Remember the keynote where you saw all these great Metro-style apps, like Socialite, the app that was integrating with Facebook, or the News app that was syndicating feeds from different sources? One thing all these apps had in common was that they all consume HTTP services. In this session, we will talk about 4 new components that will help you with consuming HTTP services in your Metro-style apps. My name is Alexandro Corradini. I'm a software design engineer in the Windows Core Networking group, and I'm part of the team that is working on the components, or most of the components we will see in this talk. I'm joined today by my colleague Suhail Khalid, who is a program manager in our team. In the next 60 minutes, we will talk about how you can connect to HTTP services. We will talk about authentication, and we will talk about how to interact over HTTP. We will also talk about consuming feeds like RSS and Atom, and how you can update feeds using AtomPub. We will then talk about a topic where it comes around consuming and challenges about consuming large content when downloading and uploading large content. Okay, let me retry that. We will talk about the challenges when it comes to downloading and uploading large content over HTTP, and how Windows 8 takes that burden from you. When leaving this session, you will be able to leverage new Windows 8 APIs to consume such services with minimal effort, so that you can really focus on the business logic of your app and on what makes your app great. And this is really the key point of this talk. So how many of you have actually written apps that consume HTTP services, like news feeds or cloud services? Okay, I just looked into the lights, but I think there were a couple of hands up. In fact, consuming HTTP services has become a very common task when writing apps today. So for those of you who have written such apps, you have probably seen a couple of challenges, like authentication. You have to deal with different services use different authentication protocols. There are different versions of authentication protocols, and you have to deal with those. Then you have to interact over HTTP. You have to format headers properly, and when you receive response headers, you have to parse strings to get out the information you need. And then there are tons and tons of different content types you need to deal with. So for Windows 8, we looked at ways how we can improve and how we can help you with this task. So let's get started and see what we have come up with. In this first section, we will talk about connecting to HTTP services. We'll talk about authentication and how a new component called WebAuth Broker will help us with this task. We will then we will interact with HTTP using HTTP client, which is also a new component we will show you. So let's jump into a demo and see how we can use these new components. So what I have here is a very simple email app. It's a Metro-style app written in C#. And nothing fancy. You see a typical layout of an email app. On the left side, we have a couple of folders. Then next to it, we have the list of messages of the currently selected folder. And on the right, we see the currently selected message. Let's say we want to improve our app by making it more social, by making it more interesting, by integrating with some social network inside. And let's say we want to integrate Facebook into our email app. Let's say how this could look like. So the first thing the app has to do is to let the user log on to Facebook, and then the user has to grant our app access to his account. So what I do here is I will log on using a test account. So I'm logging on as Alice. Once I'm logged on with Facebook, Facebook will ask Alice, do you allow this app to access the following information? And let's say Alice agrees to that. Then now the app goes ahead and fetches information from Alice's Facebook account, like her inbox messages, wall posts, and so forth. You see 3 messages from Facebook, the ones with the image on the left. And again, the first one is highlighted. On the right side, we see the actual message. It comes from Bob. And so we integrate a little bit of Facebook into our app. So let's take a look at the code and see how this actually worked. The way I implemented this is I just created a simple class. I call it my custom Facebook client, and this class is in charge of interacting with Facebook. So the first thing we saw was that we need to let the user authenticate with Facebook and then grant our app access to his account. Facebook uses OAuth 2.0 as authentication protocol. So what I had to do first is go to Facebook, grab two URIs. One is the logon URI, so essentially the page where the user can log on to Facebook, and then a so-called callback or redirect URI that Facebook will use when it has all the information gathered from the user. So with these two URIs, I'm ready to use the new component called WebAuth Broker. All I have to do here is to tell WebAuth Broker with the two URIs and call authenticate async. From here, WebAuth Broker will take over and walk the user through the logon process and the authorization process and will return once this process completes. When this process completes, WebAuth Broker will return me a status about how the process completed. It can be that the user canceled the dialog, or there was some network error, or the Facebook replied with some error. Or it could be success, in which case it means the user granted our app access to his account. So let's go ahead and see what happens in that case. When WebAuth Broker returns with success, the result exposes a property called response data, which is the data returned by the HTTP service, in our case, Facebook. Since Facebook uses OAuth 2.0, this response is a URI with a so-called access token in the fragment part of the URI. So all I had to do here is grab this response data, and I had to write a simple string manipulation method. I call it getAccessToken from URI, which just extracts this access token from the URI. And with that, I have the access token I need to talk to Facebook. That's it. That was the authentication part. The next step is we actually want to retrieve information from Facebook, like his inbox messages. For that, I use a new component called HTTP client. I create an instance of HTTP client here. Then, the next step I have to set the HTTP request header, authorization request header, and set it to the access token retrieved in the previous step. As you can see, this HTTP request header is exposed as a strongly typed property. So I don't need to worry about how to format this header properly according to the HTTP rules. All I need to do is set this property, and I'm good. HTTP client will take care of formatting correctly when it sends it over the wire. The next step is I'm setting a base address. This is optional. I don't have to do this, but we'll see in a minute why this comes in pretty handy. And essentially, I point this base address to the root URI of the Facebook Graph API. So now let's take a look at what you need to do to actually retrieve information from Facebook. I have a method here that retrieves the current user's information, like his name, email address, and stuff like that. The way this works is we need to send a GET request to Facebook to retrieve this information. And we need to send it to graph.facebook.com/me. That's the path and the URI we need to use to grab the current user's Facebook information. As you can see here, all I need to provide is the path, and that's because I set the base address in the beginning, so HTTP client will always prepend the path I provide with the base URI I specified in the beginning. Also notice that getAsync is an async method, and it fits very nicely into the new async programming model of .NET 4.5. It can use, for instance, the C# await keyword here. And that's because HTTP client was designed from the very beginning to fit into the task-based asynchronous pattern, the new async pattern in .NET. Once the async operation completes, what I get back from HTTP client is a strongly typed representation of the response message. The response message object has a couple of properties like status code, a reason phrase, response headers, and response headers, again, strongly typed, so I don't need to parse any headers anymore. I can really access headers as properties and get the information I need. And also, the response message contains content, which is the part I'm interested in this case. HTTP response message also has a couple of helper methods, like in this case I use ensure success status code because I'm only interested in the content if the response from Facebook was actually a success status code, a 200 OK in this case. So if that's the case, I want to access the content. The content can be retrieved in the Windows Developer Preview as it is today in three different types: a string, a stream, and a byte array. Now, in this case, I'm not interested in either of these three formats because what Facebook returns me is a JSON string. So what I would like to do is to get the string, the JSON string, and deserialize it into a .NET object. So for that, I wrote a simple helper method called read_as_JSON, and I'll show you how that looks like. I wrote a simple extension method, read_as_JSON, which takes an HTTP content, which is our strongly typed representation of an HTTP content. And then I just use the data contact JSON serializer to essentially pass in the content as a stream into the serializer, which will then return me the strongly typed object. And with that, I was able to retrieve the current user's information and represent it as a .NET object. So let's scroll back where we were. Now, let's take a look at what it takes to retrieve the list of friends of the currently logged on user. As you can see, same thing. All we need to do, send a GET request to Facebook, provide the correct path, and then format the content accordingly. As you can imagine, retrieving other types of information works pretty much the same. I can get the user's inbox messages, one GET request, and then format the response. Or I can get the list of messages of a specific Facebook group. Let me show you. So I pass in the group ID, specify the correct path, and format the content. Let's say we want to improve our app a little bit more, because so far all we did is just retrieve information from Facebook. Now let's say we also want to send information to Facebook. Let me show you what I mean by that. We go back to our app. So Bob sent this message to Alice, or actually to a group. And let's say Alice wants to reply to this message. So we can not only reply to emails, but we can also reply to Facebook messages. So let's say Alice replies to the message. And let me show you that this is actually live code and not some fake demo. OK, so this is IE, and it shows oh, it's already here. Cool. And shows Alice's Facebook account. As you can see, here is Bob's message, and you see a comment from Alice, which is our reply 7 seconds ago. So this really was the app actually sent a reply back to Facebook and showed it in the account. Let's take a look at the code that was necessary to write this. So, Facebook accepts content in the form of form URL encoded content. Now, think about form URL encoded content as a collection of name-value pairs. So the first thing I do is I create such a collection. I use a standard .NET dictionary of type string, and I add one such name-value pair where the name is message and the value is the actual reply message. Then I use one of the strongly typed content types that ship with HTTP client. I pass in this dictionary, and then all I have to do is to tell HTTP client to send a post request to Facebook and provide the content that should be sent along with this post. Now notice here that having the strongly typed content, form URL encoded content, I not only don't need to know how to format form URL encoded content, because the object will take care of it, but the object will also take care of setting the appropriate headers. In this case, we'll set content length to the number of bytes you're actually sending, and it will also set the content type header so that the server knows how to interpret the response content, the request content. Okay. Now, we saw quite a bit of code, so let's go back and recap. The first thing we saw was how can we authenticate with HTTP services using WebAuth Broker. Essentially, what we needed is call WebAuth Broker with appropriate URIs, and then WebAuth Broker will walk the user through this process. And WebAuth Broker will never show user credentials to the app, so this is really separated. The next thing was, once we get the response back from, once the WebAuth broker call completes, we get the response back in form of a property response data, which we then can, in this case, it was a URI, and I had to extract the access token from it. And that's it. Then we talked a bit about HTTP client. We create an instance of HTTP client. We set the authorization header, strongly typed representation of headers. We set a base address for convenience. And then we used a couple of get async calls to retrieve different types of information from the Facebook account. We also tried to send information to Facebook by using the form URL, by using one of the strongly typed content representations of HTTP client. And in this case, we used form URL encoded content. And then we used, again, HTTP client to send a post request to Facebook to send this content to Facebook. Now, let's talk a little bit more about HTTP client and how it works internally. So let's take a look at its internals. When we use HTTP client, what we see essentially is we hand off a request message to HTTP client. HTTP client sends it to the server, gets a response back, formats the response into a strongly typed object, and returns the response message to us. The way it actually works is that HTTP client doesn't do any networking at all. All it does, it hands off the request message to a so-called HTTP handler. Now, what is an HTTP handler? Think about an HTTP handler as a simple object whose only purpose is to get a request message and return a response message. The way how it achieves this is really up to the handler. So with that contract, you can imagine having not only one HTTP handler, but a whole pipeline of handlers. So a handler may get a request message, it may or may not modify it, then hand it off to the next HTTP handler, and so forth. Now, why would you want to do this, and why is this information useful to you? Well, the interesting thing is that you can actually change this pipeline of handlers as a user of HTTP client. You can add handlers, and why is that useful? Well, turns out one of the scenarios where this is really useful is authentication. For instance, think about a scenario where you talk to an HTTP server that uses short-lived access tokens. That means every couple of minutes, such a token expires, and then requests start failing because the server says you need a new token. So we have to refresh the token, and with the new token, continue with our requests. Now, instead of having the app fail a request, then let the app refresh the token and retry the request, what we can do is we can write our own HTTP handler that takes care of this. So HTTP handler will detect expired tokens, refresh them, and then automatically retry requests. So we have a nice separation of concerns here where we say this HTTP handler is responsible for authentication, and the app logic, business logic, does not have to care about authentication at all. Plus, HTTP handlers are reusable in different apps. Other scenarios where this is useful is concurrency control. The HTTP protocol has this notion of optimistic concurrency control built into the protocol. It does this by exposing a couple of headers like e-tags, if-match, and so on. And that turns out to be also a very great scenario for HTTP handlers to decouple this piece of logic from your app logic. And then there are a couple of other scenarios like logging, compression, encryption, and so on. Another interesting thing we can do with HTTP handlers is that we can not only add handlers to the pipeline, we can also replace handlers. And it turns out that one interesting scenario for that is testing. And let me show you what I mean by that. So I'm going back to our app. So we wrote this class, which is responsible for communicating with Facebook. Now let's say we want to test it. And preferably, we want to test it in an automated way. So let's say we want to test that our class behaves properly when the user's account has 0 messages. The way we would implement it today is that we would need probably a test account on Facebook with 0 messages. Then we run our test against this account and verify that everything works as expected. Now we have another test. We want to test that our component works properly if the account has 100 messages. So we need a test account with 100 messages, run a test against it, and verify that everything is fine. Now you see, this can be pretty hard to maintain and a lot of work if we want to add new tests, because we have to either have multiple test accounts or have one test account that we initialize before every test run. A better way how we can test this is by replacing the HTTP handler, the one that is responsible for communicating with the network, with our own implementation. And so that means what I would like to do here is I want to write a simple test for our component, the Facebook client we wrote. And what I want to do is to verify that our getCurrentUserInformation async works properly. So what I would like to do is create an instance of our class, call this method, and then verify that the returned information matches some predefined values. And I want to do this without talking to Facebook or even going over the network. So for that, what I do is I write a simple HTTP handler that always returns the exact same response. And you can think about ways that you can have more elaborate handlers for testing, but for the purpose of this demo, let's keep it simple. By the way, in order to spare you from watching me typing, I have prepared a couple of code snippets, so it should speed up the process a little bit. So what I did here is just define our own, we call it mock handler, that derives from one of the base types. The next thing is that I need to implement the contract of an HTTP handler. As mentioned before, the contract is very simple. All it does is get a request message, return a response message. So I need to implement two methods, send and send async. Each gets a request message and has to return a response message. So send is the sync version, send async is the async version. And as mentioned before, what I really want to do is to simply return always a predefined response. So let's create this method that always returns the predefined response. So I call it createResponse and returns an HTTP response. I create a response message and pass in status code 200 OK. So I simulate a success response from Facebook. Then I have some prepared JSON string. And all I need to do is pass this JSON string into one of the strongly typed content types. And in this case, I use string content, assign it to the content property, and return the response. With that, I have written a very simple HTTP handler that always returns the exact same response. Now, how can I use this in my test? Well, first, we need an instance of it. And then what I do is I use a slightly modified version of the Facebook client we saw before, that in this case, it takes an HTTP handler, and all it does is it forwards it to the HTTP client when it creates it. So then let me compile this. And let's see if this actually worked. Did it compile? Yes. OK, so this is the new Unit Test Explorer in Visual Studio 11. What I see here, this is my test. Let me increase the size. We have our test here, and let's run it. OK, so let me increase the size again. So two things. We saw the test passed, and we also see that was relatively fast. And the reason for that is this was just in memory, and it was just CPU cycles that were consumed for this test. I didn't even hit the network, right? And it turns out that this is really useful when you have large test suites. You can really bring down the execution time a lot by using such approaches. So let's go back. And recap what we saw in this first section. We talked about authentication. We saw how we can use WebAuth Broker. WebAuth Broker is a new component in Windows 8. So that means it's not only exposed in .NET, but it's also available in C++ and JavaScript. WebAuth Broker is protocol agnostic. That means we saw it in use with OAuth 2.0, but it also works with other versions of OAuth. It works with OpenID and other authentication protocols that are used by browsers today. We then interacted with HTTP using HTTP client. HTTP client is a new .NET 4.5 component. We saw how it exposes aspects of HTTP like messages, content, headers, as strongly typed objects, which really helps us when communicating over HTTP. We also looked at the HTTP handler pipeline, and I assure you, once you use it, you will really get addicted to it, especially for testing. I really love that feature. And it's also a great extensibility point. Now we talked about how we can connect to HTTP services. Now let's talk a little bit about consuming content. Suhail, why don't you show us that?
Thanks, Alexander. Is this on? Yes. So consuming HTTP services is not something new. You've seen it in your apps. You've seen it in your phones. You've seen it on other platforms. And it's something that we use a lot today. Two of the apps that are available on, or some of the apps that are available on your devices are, for instance, the News app that you saw Jensen use after the keynote, and even in the keynote, and in other sessions. That app is able to syndicate content from news sites or from blog posts. You saw Socialite. Not only are you able to see what your friends are up to, but you can also, the app is also able to sync all your photos. And Tweetorama, you can, put up a tweet, send a tweet up saying, you're sitting watching a presentation right now, but you can also upload photos with it. And those are the two scenarios that I want to talk about. They're very common scenarios. One is syndication, and the other one, downloading and uploading. So let's first talk about syndication. In syndication, this is a bit of a ridiculous question, but how many of you folks over here read blogs or news online? I'm expecting most of you. It's pretty straightforward. And because of that, we realize it's a very common scenario. And we wanted to address it. We wanted to provide this scenario. We wanted to enable this scenario for you in the language of your choice, whether that's JavaScript, C#, or C++. And there are a couple caveats that come with it, a couple challenges. For instance, news agencies and blog posts, they expose these feeds in different formats. You could be looking at something that's RSS 1.0, RSS 2.0, or Atom. And you don't really want to worry about that in your app development. At the same time, you could be also looking at a server that's responding back in JSON or XML. And we want to do that heavy lifting for you. By we, I mean Windows. And allow you to get back to making your app beautiful, making your app more competitive so that customers keep coming back, and at the end of the day, you get rich. That's what we're all here for, to do. So let's take a look at an API, like the syndication API, and an app that we built using JavaScript that harnesses this API. Cool. Now, you've seen this news app before, and I've modified this slightly. I've modified this so that you cannot see the images. And I want to jump into the code and show you, well, how easy is it for me to get those images from the feed? How easy is it for me to harness these feeds and worry about just improving the looks of my app? So let's go into the code. And honestly, that's it. That's all the networking that went into this app. I can create a syndication client interface by calling windows.web syndication client. And then just all I have to do then with this client is retrieve feeds asynchronously and pass in that URI. And that's it. The syndication API handles the formats for you. It handles parsing the formats for you so that then once you get the feed object back from this async call, all you have to do is if you want to get the title, you do feed.title.text. The subtitle, the last updated time. And it's really up to you. You can come up with a lot of different things to do. For instance, with a couple of UI changes and one networking line, I can get the categories and classify everything into different categories, whether it's tech, science, politics. In this case, we're going to get the images. I've already created an object that updates the UI And you've seen that UI a lot. Jensen talked about it in his keynote, in his session about grids. And I'm already updating the UI, but to get the image, that's the one-line change I need to make. So I'll just recompile this app and run it again. And we'll pick a blog. Since I'm a pretty big techie, we'll pick a tech blog, just the first one. And that's it. One line of code, and this app is looking a lot better. And the key point here is we're trying to do that heavy lifting for you. We're trying to take that burden away from you and let you focus on app development in terms of user experience, and making sure that networking just works. So just to briefly recap, what we saw was to syndicate news feeds, blog posts, whatever, you need to first create a syndication client interface. And then to retrieve feeds, you call retrieve feeds async, pass in the URI, and then it's ultimately up to you, whatever you want to do with it. You can get the title, you can get the image, like I showed you in the demo, you can get the subtitle. There's a lot of different things you can get. And I recommend you check out the sample available on dev.windows.com that uses this API. Now, many of you also author your own blogs. And as an author, you could be an editor. You want to be able to create new posts. You want to be able to update them. Suppose maybe you made a spelling mistake, or maybe you just want to add an update to the article. You want to be able to delete the post. Maybe you said something that shouldn't have been said. Or if you're not an author, you're reading these articles and you're commenting on them. And many services today use something called Atom Publishing Protocol. It's a web standard, and what the web community calls Atom Pub. And Atom Pub gives you the ability to perform CRUD operations to your feeds. CRUD stands for creating, retrieving, updating, and deleting feeds, effectively modifying your feeds. So let's take a look at another app that uses this Atom Pub client. Now, this is a sample available in dev.windows.com. And what I've got over here is an application that has syndicated feeds from my WordPress blog, and that I did using the syndication API I just talked about briefly before. And I've already authenticated on this app using an admin login. And now, because of that, I'm able to add a new post. So let's just say live demo. I'm the admin user. Let's call this demo, and let's say I'm doing a live demo. Submit the post. There we go. And we can, and like I mentioned, because we can perform different CRUD operations, we can even edit this feed. So we'll just call this live demo 2, stick to demo, and demo edit it. And now for the purpose of this demo, I haven't implemented the delete button. And that's because once again, I want to jump into the code and show you how simple it was to do the networking, to perform these CRUD operations in this app. There we go. So in this function, Atom Pub client, I have this method type variable. And the method type variable is just getting user feedback. Is the user clicking on new posts? Are they updating the post? Are they deleting the post? And it's just based on user interaction with the app. And then in this function, I create the actual Atom Pub client. Hope you guys can see it. Yes. I first use the user login and pass it to the Windows Security Credentials Password Credential Vault, which is standard across Windows runtime. And I can then use those standard credentials that I've stored in this object and pass it into the Atom Pub client. And then I can then use this client to perform various operations. So once again, based on the method type, is the user trying to create a resource? I'll pass in the client, the URI, the input item title. By the input item title, I mean the title of the blog post and the actual blog post. Or maybe I'm trying to retrieve the resource, update, and delete. Let's take a look at some of these functions. So to create a resource, that one-liner, that's it. I'm calling client.createResource async. I'm passing in the URI, the title of the blog post, and the actual blog post. And then because this is an async operation that you've seen in other sessions, all I have to do is assign it completion and error callbacks at the end of to the async operation. And retrieve resource looks the same. Update, exact same thing. And as you can imagine, for me to implement delete, all I have to do is call delete resource async. And we're good to go. So let's take a look at this app recompiled with one change. And now I should be able to delete. Voila. And that's ultimately it. With one line of change, I'm able to perform these CRUD operations. And once again, trying to resonate on this message, we're trying to do the heavy lifting here so that you can focus on the app, you can focus on the user experience in your apps. So just to quickly summarize, to modify feeds, to use Atom Pub Client, you need to first create a client interface with Atom Pub Client, pass in the credentials, and then ultimately whatever you want, whatever operation you need to perform, you can either create resources, retrieve resources, update resources, or delete resources. And in this section, what I'm really trying to get at is to consume news and blog posts in your apps. Use Syndication API. It'll take care of the different versions, different formats for you. And to easily consume and modify feeds in your app so that you can create an app that lets you author feeds, or you can create an app that lets you comment on different articles, use Atom Pub Client. It'll take away that burden once again. So let's shift gears here. Let's talk about downloading and uploading content. But first, how's that any different from, let's say, tweeting? Now let's think about this. I'm in the middle of tweeting that I'm doing a demo right now. At the same time, I may be downloading a movie. Sir, what's your favorite movie? The Matrix. All right, we'll be downloading The Matrix. And in the middle of this operation, in the middle of my tweet and in the middle of me downloading The Matrix, I lose network connectivity. As a developer for the tweeting application, what do? As soon as I regain network connectivity, all I have to do is retry again and send it up. I mean, we're not consuming that much data to do this. But for a movie download, I really don't want to tell my customer, hey, we're going to start all over again because how dare you lose network connectivity. That makes no sense. We want to be able to resume from the middle. And this is a challenge that's faced by most of you who are trying to download or upload large content. And we said, hey, let's address it. Let's make that, let's make app development a lot easier when we're doing this operation. So let's take a look at an app that uses this new API of ours called Background Transfer that is available in Windows Runtime in the language of your choice, JavaScript, C++, or C#. And I'll show you some of the neat new features that we've built into this component. So I have an app over here that's going to download a movie. At the top, I have some controls to control my download. And I have the media element where I can actually watch my movie. And on the right, I have a list box where I can see the status of the download. So let's start the download and see what's going on. And right away, you can see on the right side, it shows you the status. It first showed that the download was running, then as soon as I hit pause, it says download is paused. And these are all callbacks returned by the API. And another neat thing that we baked into this app was the ability to actually access the file that you're downloading. So I want to play this movie while it's downloading. And like I mentioned earlier, as a user, I should be able to pause, and I should also be able to resume the download. But you know what? I'm feeling a bit lucky today. I'm going to resume this download, and as you can see, the status updated. And at the same time, I'm going to disconnect the network cable right here. Oh, it's kind of tangled. I've disconnected the network cable. And at the same time, I'll also put the app in the background. Now, in Windows 8, we're striving to make the battery life of the system as great as possible. And what we do is we suspend the application as soon as it's in the background. And that's because, hang on. Let me open Task Manager. We suspend the application as soon as it's in the background. And when you're doing things like downloading and uploading content, you don't really want to tell your customers that, hey, when your app is in the background, you can't download anymore, or you cannot upload your pictures anymore. And instead, what we want to say is, what we did is we built this component brokered so that your app can live in one process and the download can continue off in the other process. So while the app is suspended, I'm going to connect this Ethernet cable again and regain network connectivity. And what we'll see soon is another process for this background transfer demo kicks up that is now doing this download. And the app is still suspended. And we can see that. We can go back into the app and see that the download is actually making progress. It finished in the background. And that works a bit fast. And what this API is really doing is attempting to address a lot of the challenges faced when downloading and uploading large content. So just to recap, and this is actually the best part of this API. For me to get all that functionality, to get that auto-resume functionality, to be able to pause and resume, that's all the code I wrote. I created a downloader interface, and then because the server is sitting in the booth hallway, I didn't really need to authenticate, but suppose I was uploading to Facebook, I would use that WebAuth broker that Alexander talked about at the beginning of the talk, get that access token, set the header, and then start upload async. But in this case, we're doing a download from a server that we really don't need to authenticate across, so we just call start download async. We pass in the URI and the file. You've seen the file interface in some session. You may have seen the file interface in some sessions. You can either programmatically use Windows storage file APIs, or you can use the file picker and let the user pick where to actually store the file. And that's it. It's an async command. You can assign it error and progress callbacks to it. And you know that part where I showed that we can get that stream of the file and start playing it before the download's done? Well, I didn't really walk through this. That final API call, that's all we did. And you can actually call this before you even start the download. As soon as you create the downloader interface, you can get that stream, plug it into a media element, and say, as soon as the download starts, these bits start arriving on the wire, the media element's going to fire up and actually start playing that video, if you're downloading a video. And what this API does is it addresses a lot of challenges you face today. It is resilient to network glitches. It has the ability to switch between networks. Suppose I was doing this download on Ethernet. I disconnect the Ethernet cable, I get up, leave my home, get on a bus, and get to school where I have Wi-Fi. The API is able to kickstart that download, resume that download, and finish it while the app is suspended. The API also has the ability to be network cost aware. You've seen in the sessions that network cost is an important thing. And the API is able to determine, hey, this download that I have right now, it is large enough, it's too large to finish on my data, on my mobile broadband account right now. So I don't want to give my user a nasty bill at the end of the month, so I'm not going to finish it. And at the same time, it's able to determine, hey, the download's too small or the upload's too small. I'll just do it. The user has enough data, and I'll take care of it. With one line of code, you can also get pause and resume, cancel capabilities. And all of this works while the app is in the foreground or while the app is suspended in the background. And once again, what we're trying to show here is that Windows is doing that heavy lifting. It's taking that burden away from addressing all these common challenges that you all face today and letting you get back to the app development, letting you get back to the user experience element of your apps. So let's just put it all together. At the beginning of this talk, we said that Windows is making connecting and consuming HTTP service easy. And to show you that, we demoed a couple of technologies. We showed you WebAuth Broker to authenticate. And we did that by calling the start URL, the end URL, and then extracting the access token from it. And that really takes care of all these different authentication protocols like OAuth 1.0, OAuth 2.0. You don't have to worry about that anymore. We then use that access token that we extracted from WebAuth Broker once we authenticated in HTTP client. And we use HTTP client to interact, to talk to the HTTP service. In this case, the HTTP service was Facebook. And we showed you, hey, use things like base URI. Use things like strongly typed headers and make your app development easy. We showed you HTTP handlers and how it makes life easy to test your apps. Then we switched gears and started talking about consuming HTTP services. And we introduced two APIs that are available in Windows Runtime, syndication and background transfer. And you can use syndication to easily consume feeds, and background transfer just in this last section to download and upload large content. And once again, what we're trying to tell you with all these new technologies is Windows will take care of that heavy lifting. Focus on the user experience. Focus on keeping your customers engaged in your app so that they keep coming back, and ultimately, we'll all make some more money. All the technologies that I showed today are available in dev.windows.com. They have samples. I recommend you check out these samples and learn more about the technologies. And I have up there some related sessions that you can really learn more about consuming and connecting to HTTP services, specific like SkyDrive, for instance. If you have any questions, Alexander and I are available at the booth and right now to answer them. Thank you.